Hello everyone and welcome to today's session on data structures. Now, we've already done a session on data structure some time back in which we discussed about the very basic nitty-gritty details of why we use a data structure, what's the point of having a data structure, what is a data structure, the different types of data structures, etc. All those details went in there. Now, in this session, I'll walk you through 10 commonly asked questions in data structures. Now, these questions are like very basic questions again, which a fresher is generally asked about when he's going for a technical interview. So just to test the waters, right? Whether he knows about data structures or not, what are data structures, etc., etc., to test his basic knowledge. And once you know what a data structure is, how it works and functions, and what all operations can be performed on it, it is very easy to write an algorithm on a data structure or write a program based on a data structure. So we'll get you familiarized in this session with the basics of what all can be done with the data structure, what the basic questions can be asked in an interview in a data structure, so that you get prepped up for your interviews coming. And also this will lay a basic foundation ground for you to go ahead and deep dive more into any of these data structures, be it linked list, be it stack, be it queue or tree, anything. So once the basics are covered, once your foundation of the building is strong, then you can go ahead and build more and more structure on top of it. So the session will basically deal with the founding or foundation of data structures. So starting off, I see many of you have already joined: Akshay, Thomas, Sushmita, Ritesh, Ketul, Sadr, right? So hi everyone, and let's start off the session without any further ado. And one more thing that I would like to stress on before I start this session on data structures is that coding, while is one thing, the more you practice, the more you will understand it. But data structure, for understanding it better, what you need to first do is understand the structure of the data that you are going to follow, how it's going to operate. So if we are talking about queue, how data is going to be inserted in a queue, how it's going to be deleted from the queue, the basic functionalities you should be aware of to distinguish between one from the other. And once that is there, once the picture, the basic layout is clear, then implementing those data structures in your programs become fairly simple and easy. It's like cakewalk after that, because you know basic programming, you know loops, you know your iterations, and you know the foundations of data structures, right? So mixing them together and getting done what you really want to do then becomes fairly simple. So let's go ahead, quickly jump on to the session. So the very first thing that anybody ask or would want to know about when they are talking about data structures in detail would be what do you understand by data structures, right? What is your understanding of data structure? Why data structures are used, basically, to be precise, right? So the very simple example that I like to quote and relate it to real life while explaining data structure is, you can see this image of a room, okay? And the image of the room has a lot of things spread haphazard here and there, correct? Your laptop is somewhere, your photos are somewhere, your books are somewhere, toys are somewhere, clothes are all spread around. Fine, a very chaotic room, to be precise. Now, in this chaotic room, if someone asks you to go and find a particular book or find a particular kind of shirt or t-shirt for you to wear, it is going to be like a madness in there for you. You will be searching here, there, everywhere, because you don't know what is where. The things are not organized properly for you to pick up what you want, right? So as soon as you enter the room, the situation is going to be pretty chaotic and dramatic in there, and this is how you're gonna be figuring out what is where, because assessing what you actually really want to assess is going to be very difficult in a situation like that. Now consider a completely opposite situation when the room is neat and clean. Your clothes are nicely folded and organized in piles in your cupboards, your books are in the bookshelves, your toys are in the toy wardrobes. Everything is nicely laid out in the room. Now if someone again asks you to go ahead and search for something in this situation, in a neat and clean room where everything is organized and put in a nice pile, it's really simple for you to go ahead. If you have to go search for a book, you'll directly go to your book rack. It's all laid out nicely, section by section, so you'll go to the section for which you want to pick the book, take it out and be done with it. Similarly, if you have to pick your clothes, your cupboard where it is, go ahead, open it, all the shirts are nicely laid out in front of you, pick whatever color you like and be done with it. Correct? So similarly, what data structures do they are like this organization of data for computers, so that number one, the computers can handle the data nicely, and number two, you can assess the data easily and fast whenever you want to assess the data. Correct? Now sorry for the no audio, and so that you don't have to wonder about where the data is and what is happening with the data, and you simply have to, so data structure, as you can see on the slide now, I think the audio problem is fixed. I hope now you will be able to hear me. So a data structure is simply a way of collecting and organizing data in a computer so that it can be used efficiently, right? So that you can go ahead and you don't have to wonder about haphazardly where my data is, what I have to search for. You don't have to worry about when you're looking for the data. So data structure helps organize this data in your computer systems so that you can go ahead and efficiently and utilize this data. You can assess the data faster. That is the simple mechanism or the simple purpose of having data structures in the programs, right? Now that is why we use data structures. Now what is a data structure we'll look at. So the basic type of data structures, so as we discussed, anything that can store data can be called a data structure, right? You're simply organizing your data together. So from primitive data structures like integer, float, boolean, char, etc., to abstract data structures like linked list, tree, graphs, all fall under the category of data structures. Now before I jump further into the questions, I have a few questions here from you. Raj has asked, can you please tell me the topics that will be covered in this session? Raj will be covering stack, trees, graphs, and as well as queues. So basic introduction of all these four things, and what is going to be covered in detail is depending on different data structures like traversals, insertions, deletions, etc. Basic functionality of dealing with every type of data structure. Okay. Nagalakshmi has asked, it is a specialized data for storing, organizing and retrieving data. That's correct. Data structures allow you to store data, retrieve data, as well as organize the data based on your requirement. So you choose which data structure to use based on what requirement you have, right? Further down, fine, the audio is perfect now, so I'll go ahead with the further questions and go ahead with stack. At any point of time, if you guys have any doubt, keep posting it on the chat and we'll keep discussing it simultaneously. So moving on, after the basic types of data structure, let's start off with the second most frequently asked question. What is a linear and what is a non-linear data structure? So how do you differentiate between linear and non-linear data structure? Now I want you guys to quickly drop in the chat whatever linear or non-linear data structure you know, or what do you understand by linear and non-linear data structures. Samanvita has asked, ma'am, can we watch this session later? Of course, Samanvita, you can watch this session later. You can go to the YouTube channel and there you can go ahead and check this session. So go to the YouTube TalentSprint IT channel. You'll get this particular video at the very front once the session is done. Street Dancer, that's a nice name. He's asking, please elaborate ADT. Okay, we saw ADT, I think abstract data types you are referring to. So ADTs are the abstract modes of organizing your data, like linked list, tree, graph. So there isn't actually a linked list or a tree or a graph. That is how you represent your data using whatever you have at hand. So you can create a linked list using arrays, you can create a tree also using arrays. So depending on what you are creating, it's an abstract concept. It is the layout that you have in front. That tree, okay, this is how you will store your tree. Now how it's actually done is what is done using the primitive data types or loops or iterations, etc. But these abstract concepts of storing your data so that the assessing of data and the retrieval of data and the manipulation of data becomes faster and easier, that is what we call as abstract data types. All right. So moving back to linear and non-linear, I see many of you have posted your comments. Let me just quickly walk through that. Which data structure big company use? Rahul Fatela is asking, like Google, Amazon, Flipkart. Rahul, there is no particular data structure being used by a particular company. Depending on what project you are working on, what is the requirement of the project, what component you are developing, whether it is a server-side component or whether it is dealing with customers or you're creating a software, you're creating a website, all these requirements come into picture when your project managers actually are deciding that which, or even developers, senior developers decide that which data structure is going to be used. So all these things come into play when you are deciding what data structure is to be used, what database is to be used, what language is to be used. It's decided at certain level, right? Then it comes down to developers that, okay, using this technology, you have to create this project, correct? So there is no one such data structure that any company uses. Any company can work on multiple data structures or even single data structure depending on the requirement of the project or requirement of the software that they are making. So ideally, big picture, you need to be aware of all the data structures. You cannot get away with knowing just one data structure, right? Okay. Prem Kumar says linear means sequencing like array. Yeah, linear is sequencing like array. Data is Saurabh says data is organizing in linear way. Okay, that is a very abstract statement, Saurabh. Data is organizing in a linear way. I'm not able to, if I would have been your interviewer, I'm not able to make out anything from this sentence. What are you trying to say? So I think you need to rephrase your sentence and then let me know. Raju Bhadwal says stack. Okay, stack is what? Linear or non-linear, Raju? Argo says array, linked list, stack, queue. Linear and non-linear tree graph. That is a perfect answer so far. Stack and queue are linear data structure. Thomas is also correct. Graph, there is a question mark. Anil Kumar says graph question mark. Graph is, okay, so for all of you out there, if you don't know by now, linear data structures are organized in linear way. So when you see an array, you see 1, 2, 3, 4, the data is organized in a linear way. If you see a linked list, again, one node pointing to the other, to the other, to the other, again, linear way organization, right? Now, moving on to graphs or trees. There's one node, there are 2 child nodes, there are 3 child nodes, there are 5 child nodes. So you see the structure of a tree or a graph, for that matter, is a very haphazard structure. You don't know which route to follow, what to do, top, down, bottom, left, right, center. So those are called graphs, and trees are non-linear data structures, right? So graph, Anil Kumar said graph question mark. Graph is a non-linear data structure, Anil. Linear means sequence, yes. Accessing of data in a linear way. All right, trees are non-linear. Samanvita said that's true, Samanvita. Linear data structure traverses the data elements sequentially. Okay, this is from Ramit. Linear data structure traverses the data elements sequentially, which is true. One by one you traverse through a linear data structure in which only one data element can directly be reached. That's again right. So let's take, for example, a linked list. You at a particular point in time, you access one data. Then you move on to the next node, you get to know the value of the next data. Then you move on to the next node, you get to know of the value of the next data. Same thing happens in the tree structure as well. When you're pointing to one particular node, you know the value of that particular node, right? But in tree, you can move back, left, right. You can go back to the parent, you can go to the left child, you can go to the right child. But in a linked list, you can either go forward or backward in the same sequence. It's sequential, right? So that is why it is called linear. And what else do we have? Nagalakshmi said data cannot be accessed in linear way, then it is called non-linear. That's again correct. Bindu is also correct. Fine. So most of you are aware of linear and non-linear concept, right? That is what I am getting from your answers here. Linear data, Priyanka says linear data structure means data is stored in linear manner and we have to go through each node. And data is organized in a linear way. Saurabh said data is organized in a linear way. Yeah, so that's all that. You assess sequentially, the data is organized in a linear way, and that is the difference between linear and non-linear. Now if you have to classify, your stack, your queue, your linked list fall into linear and your graph and tree fall into non-linear. Fine. Now further moving on to the next one, linked list. All right, so go ahead, I'll take a pause, read out what's written in there, and then I'll explain to you linked list. Gokul Adapa, I hope I am pronouncing the name correct, says what is a queue? Gokul, we'll take a look at queue in a while. And Sri Answer has asked me another question. What is data abstraction? Data abstraction is not a data structure concept. Basically, it's an OOPS concept where you hide irrelevant data and just show the relevant data to your programmers or to the customers. So let's say you don't want someone to bother about what is going on behind the scenes, you hide your data, and that is a OOPS concept. Jayant just joined. Hi Jayant. Sandeep is asking, tell me some of the websites where I learn Java easily. Sandeep, the best way and the easiest way to learn Java would be download JDK, download Eclipse, and start writing a simple hello world program. And you know, Eclipse comes with this help tool tips, right? Where you can go ahead and check how to learn. The whole Java documentary learning is there in Eclipse itself. So go ahead, download Eclipse, get yourself familiarized with how to use Eclipse. You can watch the tutorial that we have on how to use Eclipse. And that one thing only, downloading that Eclipse and sitting on the Eclipse for half an hour using the help tool from Eclipse itself is good enough for anybody to learn Java programming. Sushmita is asking how to apply for technical jobs. Sushmita, you can, if you are in a college, I hope you have campus placement options where companies come in your colleges and hire. So be prepared for that. Create a nice resume. You can upload it up on portals like Naukri or Monster, and then you can also be part of exams like CoCubes, etc., where once you get a decent score, companies call you up for interviews. So try all those options. Jevan says download documentation related to Java. Yeah, you can do that as well, but most of the documentation related to Java would also be present in Eclipse itself. So you don't even have to bother about downloading the documentation. I'm hoping you guys have all read this. Once I'm done with the comments, we'll come back to linked list. Degree final year students, what have to prepare for technical round? Okay, so Nagalakshmi is asking final year students, what do you have to prepare for technical rounds? So if you are a final year student, it is expected that first off, whatever you have studied from first to fourth year, like if you have started with C in the first year and data structures you would have studied data algorithm, you would have studied networking as well if you are an engineering grad. So all those topics and courses should be at least theoretically strong and sound in your head. And apart from that, if you have done any course or any internship during your third year, you should be well thorough with what project you created, what internship you did, what work you did in your internship, etc. All those details should be very clear to you because you have worked on it and you are projecting it in your resume that you have worked on it. So if some question is asked around those topics, you should be very clear and confident about, okay, I did this and I am aware of what I worked on. Apart from that, I think any programming language का solid knowledge, right? So if you say आपको C आता है, you should be very well aware of all the things that can be done in C. If you are asked to write a simple program in C, you shouldn't hesitate doing that. Go ahead, be confident, sit on your system and write the program, be done with it. Or if let's say you're not very confident with C because you read it in first year and maybe in third year you worked on Java. So just project Java in your resume. C दिखाने की ज़रूरत ही नहीं है. Say you are familiar with Java, you understand Java better and you are aware of this concepts in Java. Right? Now Java is also a very vast language, so if you are not aware of some topic, some territory you haven't touched so far, be very clear about that okay, this portion of Java I am not aware of, this is what I know. So the interviewer will be considerate enough and you know he will appreciate the fact that you know what your solid points are, so he'll ask you questions around that only. So that's all. Keep practicing coding. If there is a coding round happening, you should be able to clear that to reach the personal interview, right? So do that. Okay, Saurabh asked me a question. I have a doubt. The way of assessing of tree is linear way, that why we call tree assessing is not a linear way assessing. Tree assess, so see, you're confusing way of assessing with the format, the sequential and non-sequential format. Now way of assessing will of course be linear because you are, let's say, start accessing from the root node. If you are at the root node, then you'll jump onto either left or right. Whatever you decide, you will ultimately be sequential only, but you have two options, left or right. Now, in a linked list, when you have to move on to the next, there is no left or right. There's one, next, right? So that is what I mean by sequential. You go ahead one after the other after the other. There's no left, right. Like in graph, one node can have 3-4 nodes attached to it. Now, depending on your requirement, what you want to do, or depending on your programming, where you want to go, you decide in that non-linear structure where to go, right? But in linked list, one after next after next after next. That is what we mean by linear and non-linear. Okay, which Chetu has asked which way I can prepare for logical programming. Logical programming is a very abstract concept, Chetu, and see, if you have to do any kind of programming, it's all about your problem solving skills. Boils down to your problem solving skills. So if you are given a problem, how easily and quickly can you break it into small problems that can be easily solved, and the output of first small problem can be used as input to second, then so on and so forth, and then finally you get your result, right? That is how any big or small program is written. So programming is nothing but your ability to just, sort out the problem, divide it into a smaller chunk of problems, and then get it done, right? So logical programming, again, practice, I would say. Go ahead, practice more of logical programming questions. Keep programming on Eclipse so that you get to know where you are missing out. If you are writing a program and you get 10 errors in your first program, don't panic out. It's a good step to get 10 errors in your program, because then you will know why these 10 errors were coming, and then you will know that in your next program you have to avoid these 10 errors, and maybe that in your next program you will get 15 more new kind of errors, but then those 15 errors also you'll get to know, okay, this is how we are not supposed to do things, and that brings you closer to how you're supposed to do things, one step closer to what you're actually supposed to do, right? Okay, Thomas has asked, can we please talk about, okay Thomas, let me go through the chat very quickly and we'll come back to this. So let me first go ahead and go to linked list. Guys, I'd agree with Thomas, these kind of questions let's take up towards the end of the session and keep it restricted to data structures, so that those of you who have to quickly leave off can get done with the session and get going. Fine, so moving back to linked list, I hope you all read this. Linked list is a linear data structure, very common data structure, which consists of group of nodes in a sequence which is divided into two parts, correct? As you can see, there are two parts in each node. There is a data part and there is an address part, right? Now the data part is the value that is stored in that particular node, and the address part is the part that takes you to the next node in the data structure. This is the basic structure of a linked list. Now there can be different type of linked list, right? We have singly linked list, doubly linked list, and circular linked list. So let me explain to you what is singly linked list, doubly linked list, and circular linked list. So what happens in a singly linked list, we have a header node, or sometimes also referred to as a null node, that points on to your first node, correct? Now let's say the data is 45, and then it has the address of the next node, points to the next node. Now in the next node again you have data 25 and address of the next node, correct? And similarly, let's say this is your last node 13, which also has the address of the next node, but since this is the last node, the next node would be null. So once you reach null, you know that you have reached the end of your linked list. Alright, so why is it called single linked list? Because you're moving from one direction to the others. You have the address of going from this node to this node, but the other way around you don't have anything. That is why this is called a singly linked list. Now a doubly linked list, what it has? Again, it will have a head or null, which would point you to the first node, that is 45. Okay, in address. This is the simple node that we have seen so far. But what happens in doubly linked list? Doubly linked list doesn't have a node like this. The node structure changes a bit in doubly linked list. How? It becomes this. So your value goes here, address next, address previous. Now if you want to go back to previous, the previous address of this node is also present, and the next address is also present. Again, next, let's say 25, address of the next node and address of the previous node. So now if you are at this node 25 and you want to go back to the previous node, you can go back using this previous node's address, correct? And also similarly, next node, let's say null, this would also have the address of the previous node. So if you want to traverse back and forth, that can happen in a doubly linked list. Now what is a circular linked list? So circular linked list can be a single linked list or a double linked list, but the whole point is that instead of pointing to this null here, it points back to 45. That is how it becomes a circle. Can happen here also. Let's say 45 with previous address and next address, 25, correct, with previous address and next address. So this points here, this points here, right? Now let's say we have a 13. I'm drawing it in circular format just so that you can be clear. Next and previous. So previous points here, next points here, and now this next is pointing back to the first node, and this points back to this. This becomes a circular doubly linked list. Correct? So the simple funda is that you have basically two type of linked list: singly linked list, doubly linked list. Singly linked list, you go in one direction only. Doubly linked list, you go back and forth, correct, both ways. And either one of these can be a circular linked list if you are, the last node is pointing back to the first node. So either one of this becomes a doubly linked list. Now moving on to next, insertion and deletion. So if you have to insert and delete nodes from your linked list, how do you do that? So any pointers, simple one-liners if you guys can give me, and then I'll go ahead and explain to you how it's done. Meanwhile, there's too much going on the chat. Let me just go back quickly. Linked list, insertion and deletion. Anyone has any answers? Quickly point it out. Difficulty level of technical round in Infosys. It is pretty simple if you are thorough with your concepts. C, Java, be confident, and I think that's good enough, Shivani, for you to get through Infosys. Can you please tell me which scenario trees data structure will be preferred and when graph like structure will be preferred? Priyanka, deciding between data structures is based on 2-3 factors. Let's say if you have to decide between what two options you have here, tree and graph. Now if there is some data that is hierarchically organized, like you have a root node that has 2 childs which further have childs, right? That kind of structure, like let's say you have to talk about mammals, right? Let's say you talk about mammals. Now mammal classification that you do can be done in a tree structure, correct? So that tree structure can be used for scenarios like that. Or let's say if you want to talk about four-wheelers, if you want to create a class of four-wheelers. Now four-wheelers, heavy vehicle, lightweight vehicle, then heavy vehicle you might have trucks or buses, then lightweight you have cars, etc. Based on that, it goes deep down in tree hierarchy, right? So that is, if you can replicate your scenario to a tree, you go ahead with a tree data structure. That is the easiest way to decide whether you want to go with a tree or you want to go with a graph. Now let's say if you want to replicate all the graph problems that we see are, you know, no traversal or route problems, this route to this route, this shortest path, this longest path, that kind of problems are generally graph problems. So those kind of scenarios, if you want to replicate in your program in a way, that is done using graphs. So try to relate the scenarios with whether it's replicating a tree structure or it's replicating a graph structure. That's the easiest way to decide which kind of data structure you want to use. Now next, if you cannot do that, then it depends upon which data you would want to assess most. Like some data structure is a last in first out. So if you want to keep a track of what data is last inserted, because that data would be the most worked upon, you would use a last in first out. But if the first in data is more important to you, that data would be more often used and assessed and manipulated, then you use a first in first out, correct? So depending on your all these requirements, what data structure is to be used is generally decided in a program, in any coding situation that you are. Okay, I hope you got the answer to this question. Gokul is asking what is that data structure. Gokul, I think you joined in late. Data structure is simply put a way of organizing your data in the computer systems so that it makes it easy and efficient for you to use the data. If you randomly dump the data, you will have to go through a lot of trouble to assess the data the way you want. Using the concept of data structures, it is simply a way to, you know, make your job easy to assess and manipulate this data easily and at a faster pace, correct? That is the simple put definition of data structures. Please tell how I learn pointer concept. Pointer concept is fairly obsolete. I think nobody these days is asking more for pointer concept, but still, if you want to learn pointer concept and I think the good way is to go ahead and work on C, write a few programs on pointers and check, you know, add, delete a few lines here and there and check what is happening to the pointer values, pointer address and pointer value when you do that. And that is how you will be quickly able to understand that, okay, if you add 2, this is happening to the pointer value. If you add 2 to the address of the pointer, this happens. You know, do those simple calculations on a pointer in your program, and that output will help you understand that, okay, if I add 2 to the pointer value, this is changing. If I add 2 to the pointer address, this is changing. So then later on, if you have a program where you see, okay, pointer value, this, some operation performed, you are simply able to and easily able to calculate, okay, this is how I saw it and this is how it should work, right? So write a very simple program and keep doing this additions, deletions and operations on pointers. That will help you understand pointers a lot faster than anything else. Okay, Lakshya says, I'm from EC stream. I don't know about DS. How can I prepare for it? Anybody from any stream can prepare for DS. Data structure is a fairly simple concept. At least theoretical knowledge, if not programmatic knowledge of data structure, is very easy to understand. It's a very simple concept. Step by step go through what is the data structure, how it is assessing, how it is deleting values, how it is traversing through the values, and you're good to go. All right. Thomas said in a linear data structure, we can know in which position we are, add/remove element. In nonlinear also, Thomas, you can know which position you are and where you have to add or delete. Correct? You can go back up to the parent element, you can go to the next element. It is just about implementation. So adding, deleting happens in all the data structures. Queues also add, delete elements. Stacks also add, delete elements. And you traverse through all these data structures. So that way there is no difference between linear and non-linear. You assess all the elements in both linear and non-linear. You add elements in both. You delete elements from both. Right? It's just about sequential representation and non-sequential representation. Okay, Argo says we can assess graph using adjacent list or matrix. Then how it is non-linear? We can assess graph using adjacent list or matrix. So that is not the point. Again, this point I think I explained previously. It's not about how you are assessing. See, eventually in tree also you go from root to, let's say, the left node, then the further left node. So in the end it is again happening sequentially. Now whether you used a adjacency list or you use matrix to represent your that non-linear data, that is immaterial, but the representation of data that is there is non-linear, because you have multiple options to move forward to in both graph and this tree data structure. It's not about how you are representing your data structure, it's about how they are designed and presented. Raj says a session on collection framework. All right, Raj. In tree either we go left or right node, but this is already happen in DQ. In tree, Saurabh, I can I'm again not able to understand what you're trying to say. In tree either we go left or right node, but this already happens in DQ. I'm not getting what you're trying to ask. Okay, moving on to the next one. Saurabh, you need to start framing your questions better. Circular linked list. So, okay, you are comparing tree with a circular linked list. How is a tree being compared to a circular linked list? See, in a circular linked list, what is happening is node 1, node 2, node 3 pointing back to node 1. That is forming a circle, right? In a circular linked list. 1, 2, 3 and 3 pointing back to 1. That is a circular linked list. Now what is a tree? A root node, then child node, then further child node. Now these child nodes are not pointing back to the root node. You have to keep that in mind. And even if they do, first off, that would become a graph, that would not remain a tree. The basic point of a tree is you have a root node which has child, which has further child, which has further child. There's no circularity in a tree. In a circular linked list, you have this circularity. So first node pointing to the second node pointing to the third node, and third node pointing back to the first node. That is how the circular linked list is different from tree. I hope you are getting this clearly. Can we get a question in an interview in which we have to write a program on linked list? Generally you are not, if you are a fresher, you are not asked to write a program on linked list. You are generally asked for algorithms to work on linked list. And even if you are asked to write a program on linked list, maybe during a third or fourth round of a technical kind of company like Oracle or Amazon, then you very well might have to write a program as well. All right, what do we have after that? Okay, let me go back to linked list insertion and deletion now. So linked list insertion and deletion, let's say insertion can happen in 3 ways, right? Let me go back. Yeah, so first option is you have to insert an element at the first node. So let's say this is node 1 pointing to node 2 pointing to node 3. this is pointing to null, and this started from the first node, that was null, right? Now if you have to insert an element on the first node, what are the few things that you have to do? So number one, there is a node coming here in between, right? So let's say n0. Now if this is the first node, this cannot point to the n1, so this will have to go, and the pointing will change like this. Null will point to this, since this is the first node now, and this will have the address of this, making it again a sequential structure. Null pointing to no, then n1, n2, n3, n4, and so on, correct? Now let's say if we have to insert an element at the last position, again what will happen is n3 is your last. Let's say you have to insert n4 at the last. What will happen is n4, if n4 is the last element, n4 should be pointing to null, and n3 should be pointing to n4, right? So again this link will go, and what will happen is n3 will point to n4, and then n4 will point to null, since n4 is the last element. Now if you have to insert any element at some medium place in the middle of the linked list, so depending on where you have to insert that, let's say between n2 and n3 we have to insert another x element. What do? The simple logic is you get rid of this pointing, correct? The address at n2, the address at n2 that was earlier pointing to the address of node 3 will now point to the address of node x, and this address that we removed, we will make x point to n3. So that is how insertions happen in linked list. Now let's talk about deletion, correct? How do we delete? n1, n2, n3, correct? Pointing. Now if we have to delete n2, correct, there is null. Now ideally this null node doesn't have a value, it's just a representation that we have reached the end of the list. Now some representations have a null node at the beginning to represent a head starter, others don't. So this is not a mandate, and again this is not a mandatory present in most of the languages. It is just a symbol to say that we have reached the end of the list. Now if null is not even there, this is the last, there is no further address. It will have an address to the next one, right? If this address value is not present, then it is automatically obvious that there is no further node, correct? So having these nulls at the start and the end is just a pointer to tell that that is the start header and the end of the linked list. So we were deleting n2. Now if you delete n2, this address is gone. So the address of n1 should point directly to the address of n3. So what we do is we take this address of n3 from n2 node, that is n2 address, and we assign it to the address value of node 1, so that node 1 can directly point to node 3. Now after n2 deletion, n1 points to n3. Alright, that is what happens when you do a deletion in a linked list. Fairly simple. Now since you know it, you can very easily mold it to a program and do this, right? You take the address of this node from n2 address, assign it to n1 address, and that is all that you need to do when you are doing a deletion. Lakshya has asked, tell one more time about the insertion in a linked list. Lakshya, insertion is simple. If you have to insert a node at the very beginning, the beginning node address should point to the first node that was present at the beginning first, right? Then if you have to insert a node at the end, then n3 will not be pointing to null. First n3 points to null, but if n4 has to be the last node, n3 will point to n4 and n4 will point to null. Fine. And if you have to insert any node in the middle of the list, let's say between n2 and n3 we inserted this x, so first n2 was pointing to n3, but this address that was pointing to n3 will come now here because x will point to n3 and n2 will take the address of x. So this is now the new link of n2 pointing to n3 or x pointing to n3. Fine. Now moving on to the next, stack. Okay, how to traverse the list. Thomas asked how to traverse the list. List traversal is very simple. You take the first value, take this address of the next, move on to the next. From here, see, a linked list traversal is simple because it has value and it has the address of the next node where you have to go. So based on this address, you go to the next element, read that value, again check the address of the next element, go to it, read that value, again address of the next element till you reach null. When you reach null, you have reached the end of the list. So list traversal based on these addresses is fairly simple and easy to do, right? Moving on to stack. Now quickly go ahead, take a look at this, understand what is written here. Sushmita is asking how to learn to write algorithm or program in data structures. Sushmita, once you are good enough with the concept of a data structure, what is a stack, how it is implemented, how to traverse through it, how to add elements, how to delete elements, then that's the first step of writing an algorithm or program in data structure. Now let's say if I go back to linked list and you have to write an algorithm to delete an element from a linked list. How will that algorithm look like? You take the address of n3 from n2 and store it in some variable, say x, correct? Now this address of n3 that is stored in n2 will now be stored in n1. So you take n1 address and change it to n3 address. Simple. We took the address from here of this node n3 and we moved it to here so that n1 can now point to n3. And that is all about the algorithm of deletion. Just these two lines, if you can explain that this is how deletion is done in linked list, you're good to go, right? And similarly with the program, whatever language you know, go ahead and write the program in that. Okay, moving on. Stack. Stacks allow adding and removing elements in a particular order. So as you can see here, we have a stack. What happens in a stack is you add an element, but the element that is last added is the element that is first removed from the stack. Alright, so if this is a stack, you add 4, 3, 25 and 8, and you keep adding, but the last element that was added is 8, and the first element that will be removed is again 8, right? That is the simple structure of a stack, correct? The only element that can be removed is the element that is at the topmost position. Once that is removed, then you can remove 25, then you can remove 3, then only you can remove 4. Once all the elements above 4 are gone out, then only we can remove 4 from this stack. Now what next? So based on this stack is a last in first out, a LIFO structure it follows, right? So whatever element goes last in the stack comes first out of the stack, and the operations that are referred to are, if you have to add something, you use a push operation. If you have to remove something, you use the pop operation, right? And top is where the inserts and deletes happen. Also, there is no fixed size to a stack. You can keep adding on things one after the other, keep removing things in the middle if you like to remove things from the middle. That's the simple processing and working of a stack, right? Now, how to reverse a string using a stack? It's a fairly simple question and it is very easy to do. Now, generally you might be just asked, if you have to reverse a string, what data structure will you use? I have mentioned here stack, but you might just be asked that if you have to reverse a string, what data structure will you use? And that is when you have to come up with this idea that, okay, if we have to reverse a string, how can it be done and why stack is a good way to do it. Take your time, take 2 minutes and try to figure this out, why reversing a string is done using a stack and how it is done using a stack. Just the algorithm part. Krishna asked, learn data structure in Java or C, which is good for future and more easy to learn. Krishna, I would suggest whatever language you already know. If you know Java, learn data structure, learn to implement data structure in Java. And if you are aware of C, learn to implement data structures in C. Because implementing data structure in any language is basically the language at the background, right? If you know data structures, like what is going on at the top, how functionality is happening, it is fairly easy to go ahead and do it in either of the languages. Yeah, Tarun rightly said that language is a tool for writing code. Language doesn't matter, logic does. Well, I would say language also does matter, but yeah, logic is, with data structures, what is more important is logic. Then underlying language can be anything. So whatever language you are comfortable with, you can learn it to implement in that. Meghna has replied, extract each letter of the string, push into the stack and then pop from the stack. And Meghna, you skip the last step. While you're popping from the stack, keep assigning it back to the string so that you finally get the reverse string, right? Split. Okay, Harsha says split into chars and reverse the stack. So after splitting into chars, Harsha, you first have to push all those elements to the stack, and then you don't have to reverse the stack, you just have to pop the elements from the stack. All right? Yeah, so most of you have answered that push and pop. Jitu says 1 character int catch in string, push in stack, and 1 by 1 pop character. Yeah, so most of you have got it right. Let me quickly just take an example and explain it to the rest. Let's say we have a string called TalentSprint. Okay, let's say this is our string and we have to reverse it. Fine. Now what do? What we are essentially saying is that one by one take all these characters and push them into a stack. So we need a big stack for this one. Let's say this is how our stack is. So the first character we push in the stack T, then next A, L, E, N, T, S, P, R, I, N and T. So this is what we did. We took one character at a time and pushed it on the stack. Correct? Now what simply we have to do is, we don't have to do a reverse stack, etc, etc, etc. Just simple pop operation till we reach the last element or the end of the stack. So start taking out each element one by one. T, N, I, R, P, S, T, N, E, L, A, T. Correct? One by one you will take out all these elements till you reach the end of the stack, and this straight ahead gives you a reverse string. You don't have to do anything further, right? A simple program. Now this became easy since I mentioned that using stack, but sometimes students get confused if they are just asked that if you have to reverse a string, which data structure would you use to do that? Then you get confused that, okay, do I use a stack, do I use a queue, do I use a tree, what do I do? So remember, push, pop, anything that needs to be reversed can be done using your basic simple stack. Okay, now next is this algo. Create an empty stack. One by one push all characters of string to the stack. Okay, one thing that I would like to mention here is, if you have been asked to write an algorithm, make sure that your algorithm is very to the point, very specific, giving every detail of every operation that you are thinking of doing in the program. Because if you miss out anything on the algorithm part, your interviewer can immediately say that, okay, you skipped this, now without this step if you do the next step, how is it working, right? So every single small step that you think of for solving your problem, note it down, like starting with the creation of an empty stack. Correct? Any detail, big or small, that is relevant for your program, note it down. Push all characters of the string to the stack, pop all characters from the string and put them back to the string. So after popping, where are they going? You have to be put back into the string as well, right? That is the simple algorithm that you can write. So when you write an algorithm, what is it? It is simple English representation of how you are going to solve a problem. It doesn't involve programming, right? This is how you can write a simple algorithm for reversing a string using a stack. Now, if you have to check for balanced parenthesis in a sentence, by balanced parenthesis I mean, let's say we have a sentence or string like this. Okay, by balanced parenthesis I mean the number of parentheses that have been opened should be equal and in order with the number of parentheses that have been closed. Now if you have to check for balanced parentheses, if the string or the statement that you have has balanced parentheses or not, how can you do that? Ankit has asked, ma'am, please tell which language is easier to learn because my placement is going to start in 7-8 days. Ankit, 7-8 days I would say is not a very decent amount of time to learn a programming language from scratch if you don't know any programming language at all. But if you have to learn, I would say go with C, because At least then you won't have to worry about the oops object-oriented programming concepts. You just have to learn the basic fundamentals of programming. So maybe then you can kind of wrap it up in 7-8 days. So go ahead, try out C and give a good amount of time. If you only have 7-8 days and your placement is going to happen in 7-8 days, I would say give at least, if not more, 5-6 hours every day to coding practice. Alright, Akhil replied stack. Gaurav says you stack as one opening, push it and then pop when the closing brace appears. Anybody else would like to take a shot? Traverse through all the characters and check for the occurrences of that character. Okay, this is again going to be a simple push pop operation in a stack, but the only condition is, the only programming condition that you would apply here is if your character, like this is a character, this is a character, one by one we push characters onto the stack, right? If your character is equals to either of the opening braces, be it a square brace, be it a curly brace, be it a normal brace, then we do a push. Alright, and if your character is either of the closing braces, right, this or this or this, I'm just writing a simple algo. You can convert this into any programming language you would like, be it C, be it Java, whatever you are working with, right? So if character matches any closing brace, then you have to check that if closing brace is this, check the current brace. You pop the topmost element and check if it matches this brace or not, right? So let's start with the example here. We first encounter this simple brace, flower brace, put it in the stack. Then we encounter a square brace, put. So we are ignoring the characters, right? We are only pushing the braces onto our stack. So we ignored these characters, pushed the square brace, then again ignore characters, push the curly brace. Okay, ignore characters again. Now we encountered this closing brace, our first closing brace we encountered. Now what we do is we check if this topmost element that we have at the stack matches the closing brace. Now this is also a curly brace and this is also a curly brace. So in that case we pop our element from the top, correct? Take this out. Now what we are left with in the stack is this and this, correct? Now further we inquire a square brace, right? Now at the topmost element we have a square opening brace. Now we encountered a square closing brace, so we remove this also from the top. Now what we are left with is a simple brace. Again we encounter a simple brace closing, right? So we pop this also. So now our stack is empty. If you reach an empty stack at the end of your string traversal, that means that your parentheses were balanced. But in our parenthesis we have one more closing brace at the very end. Now when we want to pop this out, the respective opening brace for this out, we'll see that our stack is empty. There's nothing to pop out, but there's one more extra closing brace, which means that the parentheses are not balanced. So if one of these conditions occur, that is there is no closing brace at all, correct? Or the first brace if is a closing brace, you get this. That means also it's not balanced. There has to be an opening brace for a closing brace, correct? So all these conditions you keep in mind. If there is an extra brace at the end that is closing, for which there is no opening brace to pop from the stack, even then your string becomes, your parentheses become unbalanced. Okay, Meghna is asked to explain this again. Meghna, see, it's fairly simple. Let me just clear this off and then quickly explain it again. See, the simple idea is, if you start a brace, there has to be a closing brace for it, correct? And it should be in the same order. It cannot be that you start a curly brace but then you end with a square brace, right? Let me just check this also, give you simple examples. See, if your brace is like starting here, talent, and you close with this, this is unbalanced because in the stack you will push this brace, but when you pop you will try to match with the square opening brace, right? But you will not find a square opening brace because we have a normal opening brace. Okay, so this is unbalanced situation. Another unbalanced situation is that you have this and a simple closing brace, so there is no opening brace to it, so this is also unbalanced. Now if you have, let's say, an opening brace but no closing brace to it, this is also unbalanced, correct? These are the simple situations that you have to keep in mind that your program should be able, or your algorithm should be able to tackle, correct? So once you know all the situations that you have to handle, it becomes easy for you to write the program. All that you have to do is, whenever you encounter an opening brace, put it down. Let's say you encounter next this, let's say you encounter next this, then this, and then again the square. Okay, now when the closing braces come, they should be coming in the same order. If the closing braces have started coming, first you should have this, then this, then this, then this, then this, so that they match, and one by one you can pop all the elements out, and at the end your stack becomes empty. Fine. Now if this order doesn't come, let's say instead of this order what you get is square brace, square brace. Now first square brace you will pop this one out, next square brace you will see that this is a normal brace but closed with a square brace, which is wrong. If you start this, you have to close this first, right? So then itself you know that your program or your string doesn't have balanced parentheses, and you can return an error, right? So it's very simple. Check whatever has opened should be matched to whatever is closing. At the end you should get an empty string. If there is an opening brace, there should be a corresponding closing brace as well, right? That's a simple check for parenthesis program. Fine. Next we move on to trees. So take a look at the slide, try to understand what is given, and then we'll quickly look at it. Sagar has very nicely given the step-by-step procedure of doing that balanced parenthesis situation. Instead of pop, it should be peak. If the condition matches, then pop is done. So you just take, which is very correct, you just get the topmost value, check if it matches, and then pop it out. And if it doesn't match, the program doesn't work, right? Shubham also explained the same. Okay, so moving on to tree. Tree is a data structure made up of nodes, vertices, edges, without having any cycle. Okay, so the tree with no nodes is called the empty node. A tree that is not empty consists of a root node and potentially additional levels of node. By which they mean is that a tree has a root node R and can have multiple child nodes C1, C2, C3, C4, etc. Right? Now, if another thing to keep in mind is, if there is only one node, that is A, and it is pointing back to itself, this does not qualify ideally as a tree, but this is what a tree cycle is. One node pointing back to itself. A is the root, but A is also the parent of the root, right? Now, there is some certain terminology that is involved with tree. What is all that? First off, let's create a simple tree. 45, 13, 72, 4 and 8, and 56 and 93, right? Now in this tree, you need to remember the tree terminology, because if in your interview some questions are asked around this, then you should be able to, answer to these questions. So what is a root? Root is the topmost element which has the childs. So 45 becomes your root. What is a child? Anything that comes down from 13, 72, 4, 8 is a child in the tree. What is the parent? If in reference to 4 you ask the parent of 4, it is 13. The immediate ancestor is the parent. So parent of 13 is 45. Similarly, parent of 93 is 72. Right? What is a sibling? All the nodes that are at the same level. So 4, 8, 56 and 93. The nodes at the same level are siblings. So if you are asked what is the sibling of 13, it is 72. Okay? Further, let's talk about descendants and ancestors. So if you are asked what are the descendants of 13, we have 4 and 8. If there is anything under this, let's say 1, then 1, 4 and 8 are the descendants of 13. Similarly, ancestors is what we have on the top. Ancestors of 8, let's say. Ancestors of 8 would be 13 and 45. Ancestor of 72 would be 45. Now, what is internal node? An internal node is a node which has at least one child, right? So 13 is an internal node, 4 is internal node, 45 is internal node. But what is a leaf? A leaf is the nodes which have no children. So 8, 56, 93, they have no children, correct? So they are called as the leaf nodes. Now what is an edge? Edge is this connection between two nodes. This is referred to as edge. Why do we need to know this? We'll come to know further down. What is the path? Path is a sequence of node and edges. So let's say if you are asked what is the path to reach to 56 from the root node. So it is 45 followed by this connection, then 73, then connection, then 56. This is the path from 45 to 56, correct? So now next is what is the level of a tree. How do you calculate the level of a tree? It is 1 plus the number of connections between the node and the root. So level of, let's say, 4. 1 plus number of connections between this node and the root node. So how many connections are there between this and this? 1, 2, correct? So level of root node 4 is 3. It's a third level, correct? Similarly, if we have to calculate level of node 1, so level of node 1 is equals to 1 plus number of connection between node 1 and the root node. How many connections are there between them? 1, 2 and 3. So level of node 1 is equals to 4, correct? Now next is the height of a node. Height of a node is the longest path from root node to the node, and height of a tree is the longest path from the root node to the child that has the last leaf, right? So the height of this tree is 1, 2, 3. Height of our tree becomes 3. Okay. Further, what is the depth? Depth is the edges from tree's root node to the node. So let's say if we ask what is the depth of 56, how many edges are there from root node to 56? 1, 2. So depth of 56 is 2. Depth 56 is 2. Alright, this is the simple terminology that you all should be aware of when you talk about a tree. Okay, I see some what is the level of root node is 0, right? Yep, Meghna, level of root node would be 0 because there is no further ancestor or connection up it, right? So it starts as 0. Level of root node is 0, and then further down we continue. Okay, so level goes 1 plus, and since there's no further connection, so the number of connection is 0, but we add 1 to it. So 1 plus the number of edges above it, right? So 0 plus 1, our root node is at first level. The next two nodes 13 and 72 then become at second level. Similarly 4, 8, 56, 93 are at third level, and the first node that we have is at fourth level, correct? This is how it works. Now once you're clear with the tree terminology, guys, what next comes is tree traversal. How do you traverse a tree? Now these questions are fairly interesting, okay, because they make you do programs in certain way, and then not even programs, even if only the algorithms, they get pretty confusing. So let me start with the simple one, that is the breadth first traversal. How does it work? It works in traversing the nodes in order. So you start with the root node, that is 1, then 2, 3, then go down to 4, 5. That is your breadth first traversal order. Now similarly, if you have to do depth first traversal, depth first traversal is done in 3 types. It is in order, pre-order and post order. Okay, now what happens in all these in order, pre-order and post order? In order traverses in this order: left, root and then right. Okay, remember these orders, only then you will be able to, you know, clearly distinct between this. In pre-order we have root, left, right, and in post order we have left, then right, then root. Okay, So now if you have to traverse this simple tree that we have, fine, let's say in order. How do you do it? You start with the leftmost node, then move to the root, then right. So the leftmost node in this tree is our node number 4. So first we have 4, then root, that is 2, then right, that is 5. Now this part of the tree is done, this becomes left. So left is done, again root, that is 1, and then right, that is 3. So if you traverse your tree in order traversal, you'll get elements like this: 4, 2, 5, 1, 3. Okay. Now I want you to give me the pre-order traversal result of this tree. We have root, then left, then right. Now give me the pre-order traversal of this tree. Meghna, I see you're confused about the level and the height of the tree. See, the formula for the level is very simple. The level of any node is 1 plus the number of connections between that node and the root. Now since root node doesn't have any connection between itself, so the number of connections between the node and the root becomes 0 for the root node, correct? And you just add 1 to it to get the level of the root node, which becomes 1. Now in the next you add 1 more, so the next level becomes 2 and 3 and so on. That is a simple formula to calculate the level of a tree. Now about the height of the node. The height of the node is the number of edges on the longest path between that node and the leaf node. So you just count the number of edges between that node and the leaf node. In this case, between 45 and 1. So the height of this tree becomes number of these edges, that is 3. That's a simple formula. You don't have to be very confused about it. 1 plus the number of connections and the number of connections between the root and the leaf. Okay. So some of you have given me the pre-order traversal. Let me go back there. 2 4 5 1 3 1 2 4 5 3 and 1 4 2 5 3. Okay, I have got 3 answers. Well, actually 4 now, and out of which only 2 are correct. Arjun's answer is correct and Meghna's answer is correct. 1 2 4 5 3. And now Shivani has corrected her answer. So let me quickly explain what is happening here. Root, left, right, correct? So you start with the root, that is 1. So 1, then left, that is 2. Then again 2, keep going. Root you have taken, go to left, that is 4 and 5. Now once this part of the portion is again done, you are done with the root, you are done with the left, then go to the right, that is 3. Correct? Similarly, post order, left, right, root. Now how does that work? Left, right, root. So you start with the leftmost, that is 4, then right of it 5, and then root, that is 2. Now once this is done, this is the left, the right is 3, and the root is 1. So this will be your post order traversal. Correct? So I hope now you have understood the in order, pre-order and post order, right? Now quickly take your time and do the same for this. I'll give you the order written here for those of you who haven't remembered it yet. In order is left, root and right. Pre-order is root, left and right, and post order is alright. So let's start with the in order. I want everyone to quickly go, the tree is fairly simple, okay, it is not very complicated. Go ahead and give me the in order traversal of this tree, the first one. Let's go ahead and take a look at the first one, in order traversal. I've got some answers already for the in order traversal. Let me check that. 4, 10, 12, 15, 18, 22, 24, 25, 31, 35, 44, 50, 66, 70 and 90. So Sagar and Meghna have both answered it right. Sagar has answered the pre-order as well. So all of you are able to get the in order and you have moved on to the pre-order as well. That's good. Cool, and post order is also given. So let me quickly give you the answers for those of you who are not able to yet figure this out. In order is left, root, right. Fine. So you start with the leftmost, that is 4. So 4, root 10, right 12. This is done. Now this becomes your left. So left, root 15. Right, you have this. Now in this, again left, root, right. Keep repeating this. So that is 18, root 22 and right is 24. Fine. Now once that is also done, get to the root, that is 25. Again you move on to this part, right? In this part what you will do is start again with the leftmost. So then left, root, right. Now root, left, root, right, correct? And similarly I think you all are able to do it. Repeat, keep repeating this pattern, root, left, right, and for post order repeating the pattern left right root. So let me quickly show you post order as well. Left 4, right 12, root 10. This is done. Left is done. Now this says left right root. So left ka corresponding right you will check. Again in that left right root. 18, 24, 22. And then after 22 you go to the root, that is 15. Right? So you go to 15. Fine. Then corresponding to this half you go to this half. Okay? In that leftmost 31. So 31, 44, 35. Then 66, 90, 70, 50 and finally 25. Okay? So most of you are able to crack this. Pre-order, I'll leave it for you guys to figure out on your own. The pattern I have given to you, root, left and right. Fine. Moving on to binary search tree. What is a binary search tree? There are 3 easy points to quickly remember about the binary search tree. The left element is smaller than the right element. Okay? The left part of the tree has all elements smaller than the right part of the tree. Okay, so if your root node is 45, all the elements on this side will be smaller than all the elements on this side. Correct? And there's one more thing about this binary search tree, that no element can be null in a binary search tree. There has to be a value to the elements. So it's a normal tree, but just these rules apply in the binary search tree. Now further, let's quickly go on to queue. We are already overdue. I think most of you could be late for your prior assignments. So what is a queue? Queue is an abstract data type again. First element is inserted from one end called rear and the deletion happens from the front. Other end called front. Okay? And queue is a first in first out. So our stack was a last in first out. Queue is a first in first out. So situations where you need a first in first out data structure, you use a queue. The process to add an element is called enqueue and process to delete an element from a queue is dequeue. Now corresponding in stack was push and pop, right? In queue, with respect to queue, it is called enqueue and dequeue. Alright, so that simply about queue. I'll quickly show you the structure. Alright, let's say okay, let's say we implement queue using an array. Fine. So we keep adding elements from the insertion happens from the tail, that is rear, right? So we add, let's say, tail and front and rear are marked the same. First element we added is, let's say, 4. Okay, now next element would be added at this position, correct? Let's say 5. The next element would be added in this position, let's say 71. Okay, now we keep adding and adding and adding. So the rear of the tree comes finally here after adding all these elements, and the front remains at the front, correct? Now when deletion happens, what will happen is the first element that was inserted in this queue will go out, correct? So the first element that is inserted in the tree was 4. Now when you delete this element, how you delete the element is very simple. Front, instead of pointing to 4, it points to 5. So whatever element the front points to, that is the first element of your queue. By default 4 is deleted. Now if you point your front to 71, your 5 is deleted. And as similarly for addition, rear keeps moving forward and elements keep being added. Alright, simple process. Fine. Circular queue. Meghna has asked for circular queue. Meghna, circular queue is again fairly simple. Just assume that this is a let's say assume that this is a cassette tape, right? We have all heard music in a cassette tape. Now if you add sections to the cassette tape and write elements there and then just wrap it around, okay? So the last element, I'm just giving you this for conceptualization so it is easy for you to understand. Let's say the last element is 81 and the first element is 4 only. So the rear points to this. Now in the circular queue, the rear and the front becomes the same. So after 81, when move on to the next, you get the element 4, right? So this idea of having this circular thing, right, the circular tape feeling around, that connects your elements together. So you have, in normal serial list, you have 4, 8, 13, 14, 81, let's say. Now in this circular queue, 4 and 81 would be adjacent to each other, right? Your elements, those two, front and rear, would be next to each other. Now if you remove the element 4 and make it point to the next element, still front and rear will remain the same because you are having the idea of a circular queue. So front and rear would be right next to each other in a circular queue. Alright, so that was the session about data structures. We saw stacks, we saw trees, we saw linked list, we saw queue, and we have seen traversals and other questions around that are commonly asked around all this. So stack, we saw how, you know, certain real life scenarios like matching braces or string reversals, those kind of questions are done using stack. And then we saw how traversal is done in a tree, right? So that was about the session, guys. I hope you understood the basic implementation of all these data structures, how they are working, how they are used, why they are used is more essential. Once you know understand why something is used, it becomes easier to understand how it is used. All right, and I missed out on some of the comments in the middle when there were a lot of questions around interviews and what language should I prepare for, etc, etc. So I'll try to answer all those questions in the once the video is posted in the comment section. I'll try to answer all those questions, so you can go ahead and take a look. If you have asked a question, go ahead and take a look at the comment section of the video and your questions would be answered there. And what next I have is if there's certain questions. So data structure was highly requested in the last 2-3 videos. Many of you asked for a session on data structures. That is why we had this session today. And if there's some topic or some concept that you would want to brush up on, any question that you want me to take up in the next session, again, drop a comment or drop your comment here in the chat and we'll take it up in the next session. And I'll see you next Monday when we have the next session on 25th, I guess, next to next Monday.